Black holes are one of the most mysterious and fascinating objects in the universe. They are formed when a massive star reaches the end of its life and collapses under its own gravity. This process begins when a star exhausts its nuclear fuel, which is the energy source that keeps it shining and balanced against the inward pull of gravity. As the fuel runs out, the core of the star becomes unstable. The outer layers are blown away in a massive explosion known as a supernova, while the core continues to collapse. If the remaining core has a mass greater than approximately 3 times that of the Sun, the gravitational force becomes so strong that nothing can stop the collapse. The core shrinks to an infinitely small and dense point called a singularity. Surrounding this singularity is an invisible boundary known as the event horizon. This is the point of no return. Once any matter or light crosses the event horizon, it is forever trapped inside the black hole due to the immense gravitational pull. As the black hole forms, its gravity distorts the space and time around it. This creates a phenomenon called gravitational lensing, where light from distant stars bends around the black hole, creating a warped and magnified effect. If you could observe this process up close, you would see the fabric of space stretching and twisting in a swirling motion as matter spirals toward the black hole. The region just outside the event horizon is known as the accretion disk, a ring of superheated gas and debris that glows brightly as it orbits the black hole at nearly the speed of light. The friction and immense gravitational forces cause the disk to emit powerful X-rays and gamma rays, making the black hole visible to astronomers, even though no light can escape from its interior. Black holes vary in size and type. Stellar black holes, which form from the collapse of massive stars, are the most common. However, there are also supermassive black holes found at the center of galaxies, including our own Milky Way. These supermassive black holes can have masses equivalent to millions or even billions of suns. Scientists believe they formed from the merging of smaller black holes and the accumulation of vast amounts of gas and dust over billions of years. Intermediate mass black holes, which are larger than stellar black holes but smaller than supermassive ones, are still being studied, and their formation is not yet fully understood. As matter falls into a black hole, it experiences a process called spaghettification. Due to the extreme difference in gravitational pull between the head and feet of an object, the object is stretched into thin, elongated strands. This happens because the gravity near the singularity is so powerful that it pulls more strongly on the closer part of the object. Any astronaut or spacecraft that ventures too close would be stretched into thin, noodle-like shapes before eventually being torn apart. This dramatic effect illustrates the immense and mind-bending power of black holes. Black holes also have an impact on their surroundings. They can influence the orbits of nearby stars and even pull in entire star systems. As they consume matter, they emit massive jets of high-energy particles that can travel across galaxies. These jets can be seen as bright beams of light, sometimes reaching millions of light-years into space. The intense gravitational waves released during the collision of 2 black holes can ripple through the fabric of space-time, creating detectable waves that scientists on Earth can observe using specialized instruments like LIGO and Virgo. Despite their incredible power, black holes do not last forever. Over time, they slowly lose mass through a process called Hawking radiation, named after the physicist Stephen Hawking. This radiation occurs because of quantum effects near the event horizon, where pairs of virtual particles are created. One particle escapes into space, while the other falls into the black hole, effectively causing the black hole to lose a tiny amount of mass. However, this process is extremely slow, and it would take longer than the current age of the universe for a typical black hole to evaporate completely. Black holes continue to be a subject of intense research and fascination. With advancements in technology, such as the Event Horizon Telescope, scientists have been able to capture the first-ever image of a black hole, revealing its dark silhouette surrounded by a glowing ring of gas. This groundbreaking image provided direct visual evidence of black holes and confirmed many of the predictions made by Einstein's theory of general relativity. Black holes are not just cosmic voids, but dynamic and influential forces that shape the universe in profound ways.